So this paper is about, it's part of a couple of papers that I'm working on algorithmic price discrimination. And I know this is a law and tech workshop. This is in intersect, right? Not to I'll just do it like this. So it's in the intersection between economics and tech. So I'm hoping to get your sense how this. As you'll see, the word algorithm here is a bit, maybe too ambitious. This is a pretty, modest lab experiment that tries to pinpoint a very specific phenomenon that I'm studying. So without too much introduction, let's just go straight to it. So we know that there is an increasing use of algorithms to set prices in consumer markets. It's happening all over the place. The big tech, Uber, Amazon. We know that more than half of the sellers are using algorithms to set prices, but it's also happening in many other places. So I just put HubSpot here because it's a software company that provides software products to small and medium-sized companies that can be used to price discriminate. So, even your local, shop and so it's really penetrating all levels of the online economies. And there's a lot of important things about using algorithms to set prices. A lot of the literature has been focused on price collusion, whether algorithms include consumers' privacy is, of course, a main concern. But my focus here and in my research mostly it's about price discrimination. So the idea is to use algorithms to estimate consumers' willingness to pay, how much they're willing to pay for a product, to set either higher or lower prices, and more accurately and granularly without them. So, between Econ 1 we have usually single price. There's supply and demand. Here it's just demand, and there's a single price. And then, if you want to price discriminate, usually we think about it as maybe setting two prices: a higher price for older people and lower price for younger people, perhaps. And with algorithms, the idea is that you can set more and more granular prices, carve the consumer market into thinner and thinner segments, and that way extract more of consumer service. And importantly, and this is where the point of this project comes in, is that there's been a shift from using immutable characteristics such as age and sex and race, etc., which has been dominant characteristics on which price discrimination has been based on in the past, to behavior. So your browsing history, etc., how you behave online, which we have some empirical findings that show that this is much more indicative of your willingness to pay for a product than your demographic characteristics in recent years. And seemingly unrelatedly, this is what I'm trying to connect here. We've known that consumers contract, at least in the US, and you can tell me how it works here, and I'm not certain, but I'm imagining it's not very, very different. It's evolved under the assumption that consumers lack any bargaining power. It's basically, take it or leave it. And the idea is that perhaps if price discrimination is based on your behavior, then perhaps as a consumer, you might be able to bargain with the algorithm over prices, which is something that you couldn't really do in the past through your behavior online. So the idea of the punch is the algorithms are cold-hearted, but so are consumer contracts, but at least the algorithm personalizes, which might not be a bad thing. So for example, when you take the bus, when Uber prices surge, so you might just do it for any reason, because I know you don't want to pay much. But another reason why you might do it is because if you take the bus today and you tell Uber, no, I'm not taking the Uber for the higher price, then tomorrow you might get a lower price than someone else considering being offered the same ride going from A to B, etc. There's a bunch of other examples for that. And so again, it could be regular behavior, but it could also be strategic signaling of low willingness to pay. That's in the econ jargon. You can basically tell the seller, no, I'm not buying the product because I'm not willing to pay so much. If you lower the price, then I might buy it. And algorithms might pick up on that behavior. I mean, we know that they do. And the question is, basically, with this paper, follows up on a previous theoretical paper, is asking the empirical question of whether consumers, whether us, might actually be inclined to do so. That's basically the point. So this paper uses a pre-registered, incentivized, randomized, so it's a bit monthful experiment to test whether consumers learn to strategically bargain with a pricing algorithm and the effects of regulating it, because we're doing law after all, so we remember the legal angle. So a quick summary of the results, and then I'll dig deeper. So we do see that participants gradually learn to bargain with the algorithm to decrease prices by strategically avoiding purchases. If you don't purchase something in anticipation that the price will drop, they hold on a purchase. We see that disclosing that fact makes participants more strategic. So disclosure in a very simplistic and non-realistic way, but just this in principle could have some positive effect positive in the sense of making consumers behave more, be smarter, behave strategically with pricing algorithms. And we have some evidence that participants use their data protection rights, giving them control over the data that's being collected, also in a way that's not just privacy oriented, but also strategically. Because when you refuse to give your data to a seller, you might have some privacy concerns that make you do that, but it also might affect the data that they have, and therefore it can also affect the prices you might receive. So that's also sort of a novelty that this paper is trying to push for, consider. Let's get the literature, we're a bit short on time. So the experimental design, and this is, I guess, the most important part, at least for me, as a kind of an economist nerd. I mean, obviously the results are important, but if you're convinced by this slide, then I think you should more or less be convinced by whatever comes next. So pay attention. So in the experiment, participants could play 1, 2, 3, or 4 rounds, and in each of those rounds, they were given $10. They were asked to make a very simple decision whether they want to use some of those they could just keep $10, or they can use some of the $10 to buy a $10 Amazon gift card, keep the change. So basically, and this is a very, as I said in the introduction, just not to get your expectations too high, a very simple algorithm here was that at first, in the first round, the Walmart gift card cost $7. They could decide whether they keep the $10 or buy the gift card and get the $3 change. And then in each round, the price changed based on their decision in the prior round. So if first it cost $7, and then so here's the diagram. So if first it cost $7, and if they decided to buy the gift card, then in the second round the price increased to $8. And if they decided not to buy the gift card, then it decreased $6. And so on for each of the rounds. Then you can see by round 4, there was I tried to stay here. So then in by the 4th round, the prices could potentially vary anywhere between $4 and $10, depending on the purchase history. Right? This is basically intend to kind of get to the idea that you bought an Amazon or you took an Uber 300, 400 times, whatever. Then you have a lot of data about your purchase history, and this is where the pricing variation comes from, even if they don't know anything else about it. And there were incentive, of course. So 10% received their choice of payment, either $10 or the gift card and the change for one of the rounds. So the idea was to it's kind of common economic experience. I don't think I should get too much into it. I can also talk more about it in the QA, but for those of you who are interested, so the idea is to choose just one round in random, because both to save money, experiments are expensive, and but more importantly is because I wanted to avoid an income effect. So the idea is that if you bought a Walmart gift card in the first round, you might tell yourself, well, now that I have one, I might not need another one. like maybe I'm good with one. Like, or if you have two, then you might not want a third one, and so on. So the idea is kind of by the fact that they can only get the payment from one round, it means that they have an incentive to treat each round the same way in some sense, in the sense that the gift card should be worth to them just as it was in every other one, which is kind of important, and we'll see later. So we can maybe it's not clear why I'm kind of emphasizing this point. So two main identification features, and then I'll move on to the results. So in each round, and this is the most important one. This is basically why this experiment identifies the effect that I'm trying to identify. So in each round, participants playing their last round serve as control for participants expecting to play additional rounds. So it's an experiment. We're supposed to have a control and treatment group. Might have not been clear what's the control and treatment here. So remember, as I said before, people play 1, 2, 3, or 4 rounds. Some people play just 3 rounds. Other people play 4 rounds. So there's all options. So basically, what I'm doing is I'm comparing, for example, a person who's playing their second round and they're anticipating play. And they know who knows that they're going to play additional rounds to a person who knows that the second round is their last. So basically, if you're playing your second round and if this is your last round, then you have no reason to be strategic because this is the last time that you're going to face the decision whether to buy, and the decision won't have any implications for the future because this is the last round. So this is kind of just a way to illustrate it. These are simulations. It's kind of based on a set, it's kind of building on a theoretical paper. These are simulations on the way. But I'll just do it. So basically what you see here is on the x-axis you have the person's willingness to pay, how much they value the gift card, and on the y-axis you have the price. And the idea, this gives people like what's the rational thing to do. So just look at so if you're at the round 4, if you're playing the last round, this is basically just standard like intuition that we all have. Green is buy, red is don't buy. So, buy the product when the price is lower than how much you value it, right? Very simple. And don't buy it if the price is higher than how much you value it. Very simple intuition. But then it breaks down, right? Because if you're playing the third round, you know that you have one more round to play. There is this section, this line, this stripe, where you might want to rationally avoid the purchase, even though the price, this is the main point, even if the price is lower than how much you value the product, because you want to reduce future prices, right? So you're avoiding an otherwise efficient purchase to reduce future prices. This is the strategic behavior, and you see that as you go back, the strategic incentive is stronger. So if you're playing the first round and you know that you might have 3 more rounds to play, it means that your decision today is much more impactful on future prices because today you're just going to lose out on a $7 Walmart gift card, but by forfeiting that purchase, you will gain by decreasing the price you're going to be offered for all future rounds. So this is the idea. And also very important, the participants were only informed about the number of rounds they played before the last round started. So this is kind of another kind of small but important thing to understand, which is that if you know how many rounds you're going to play in advance, then you might, as you just saw in the graph, you might behave differently. So if someone plays their first round and they know that they're going to play 2 rounds, they have different incentives than someone who knows they're going to play 4 rounds. So their behavior will change very early on. And the idea, the first point was that I'm going to compare people playing, as I said before, like a person playing the second round when it's their last round versus a player playing their second round when they're anticipating to play additional rounds. So to be certain that I'm comparing comparable people, I need to know that they experience the same thing in the experiment, right? In an experiment, if you want to attribute anything what you're changing, you need to make sure that nothing else is changing. This is the only thing that's changing. So the idea is that in each and every round, I'm going to compare two pools. The only difference between them is the rounds we're going to play and not stuff that happened in their past, in the experiment. I mean, again, we can go back to it in the Q&A. It's a bit fun for the experimentally inclined people. I'm kind of running out of time, so let's talk quickly about the conditions, and then I'll go straight to the results. So as I said, there's people playing 1, 2, 3, or 4 rounds, and they know that the prices can change between the rounds, but they don't know that their decision might affect prices. And then the disclosure condition goes straight at that, tells them that their decision might affect pricing in future rounds. So that's a disclosure condition. And then what I call the cookies or erasure is basically giving people right and the power to decide after every round, whether or before every round, whether they want their decision to be coded and saved by the algorithm, which means that they can basically tell the algorithm, like, forget me, or like, don't save my information. And the effect, like the way it's captured in the experiments, is that if you invoke that right, then the price in the next round will be the same. So it won't change. So if it starts at $7, and then in the second round you say that you want your data to be erased, you refuse cookies or whatever, like either of those options, means that in whatever you decide, the next round the price will be the same. So these are the conditions. I also listed the willingness to pay, but let's kind of skip those stuff. This is kind of the first look at the results. These are not results, actually. It's more like descriptive results, but I mean, you shouldn't take too much from it, but people like this graph, so I keep it. But don't believe it too much. So basically what you see here is the price and the willingness to pay, how much people value the product. And this is, I kind of skipped it, but the idea is that the willingness to pay here was elicited in a non-strategic way. So this is the extent that you believe the procedures that I used, and you can because I just skipped them, but if you read the paper. So you should hopefully believe that this is kind of true willingness to pay, how much they actually value the product. And then in the blue circles are people who didn't purchase the gift card, and in the red circles are people who did purchase the gift card. So basically the idea, and the dashed, kind of the point of this graph is that the dashed black line will just represents where price is equal to willingness to pay. So basically, if nobody was strategic, you would have seen a complete separation. All the circles below the dashed black line should have been blue, and all the circles above the line should have been red, which is again just the idea of if the price is lower, then you should then how much you value the product, then you should buy it, and if not, then you shouldn't. So you do see some separation. People are not crazy, but it's not perfect. And kind of the idea, just to point to this graph, is to tell you that the people who are suspecting that they might be behaving strategically are people who are the blue circles above the graph, right? People who value the product more than its price, but still didn't buy it. So these are kind of our suspects who might be behaving strategically to reduce future prices. Let me see that. So this is, there are a couple of results that I would call main results, but this is kind of the first one that you can actually see something that should be causally interpreted if you believe everything I told you so far. So here, what you see is the percentage of people who purchased a gift card in each round, round 1, 2, and 3. And what we have plotted here is the green line are people who are playing their last round, right? So in one round, these are people for whom one round is their last. For round 2, it's people for whom round 2 is their last, and so on. And in the blue line are people who are expecting to play at least one more round. 1, 2, 3, or more, whatever. And the red line is the difference, which is the important one. And what you can see here is, and it's going to be a recurring feature in the next results as well. So we have this kind of concave sense. I mean, it's still not very pronounced, but you can see that in the first round, people, there actually wasn't any difference, which I didn't anticipate. I wasn't sure. Like, you could imagine that people would have behaved differently as early in the first round, but there was kind of a notion that perhaps people need to interact with the algorithm to understand what it's doing, right? Because I mean, they know the prices are going to change, but I'm not telling them in what way and how their behavior is going to change that. So that kind of makes sense if you look at the pre-registration. It's kind of, I didn't put any money on the first one. I honestly didn't know how it's going to turn out. Then in the second round, we see a very large and significant difference in the in how we expect, which basically shows that people are playing or expecting to play more rounds, are much less likely to purchase a gift card. Right? The blue circle are people who are expecting to play additional rounds. They're much less likely to purchase. So this is kind of the main point. And in the third round, it kind of drops, becomes, I don't remember if insignificant or maybe marginally significant, but it's not really significant. And the idea, I mean, the shape, so the idea of the shape is that there's a trade-off. So on the one hand, going from round one to round two, you gain experience, you interact with the algorithm. When the rounds keep going and you get closer to the end, then also your strategic incentive to avoid a purchase lessens. Because when you're expecting to play right in the third round, you're expecting to play just one more round. As we said before, you don't really have as strong of an incentive to avoid a purchase as you did in the previous round. So this is so the concave. So this is the idea of the concave structure. Obviously, it could have been significant also in the third round, but it wasn't. And this is where the disclosure comes in. So when we tell them, so this is basically the same graph, just now the purple line are people who are expecting to play additional rounds, but are also told that their behavior might affect future prices. So here you can see that the effect is just much stronger. And now it's also significant in the third round. It's all very close to each other, but you do see from the previous graph kind of a large increase in the magnitude of the effect. So again, in the first round, there's no effect. People are not interacting with the algorithm, so they don't, even though they could understand because the disclosure did tell them something about it, but I think this is an interesting point. I mean, I can't prove it because it's not something that is part of the term, but I think it suggests that it's important for people to actually interact with those pricing algorithms to understand how they work and how to shape their behavior around them. And then it really jumps round two, and then it decreases. At round three, it's still significantly different, but on decrease. And then luckily, otherwise I wouldn't be here presenting this paper. At round four, there's no effect because this is just, I mean, obviously there's no effect because everyone's, when they're playing round four, it's their last round. So there was any difference there, I should have thrown the paper away probably. Let me see how much time I have. Oh, just like I'm busy all the time. Sorry. Let me jump, say a few, like 2 minutes maybe, on the cookies and erasure. So first, like basically there wasn't a lot of difference. I thought that maybe asking people beforehand versus afterwards would have made a difference. Like most of the results it didn't, just being honest about it. But there is at least one interesting result, which is whether people use their privacy rights strategically. It's kind of what I'm trying to push for in some of my work in this one as well. So basically what you see here is for each round, you have the people, now in the y-axis, it's not, like before, it's not how many people purchase the product, but it's how many people agreed to allow the algorithm to retain the data, right? So, and this is broken down by people who purchased. The darker blue are people who purchased, and the lighter blue are people who didn't purchase. So basically what you see in both the second and the third round is that people who did not purchase were much more likely to allow the algorithm to retain the data. or just saying it's the same way the other around, they were much less likely to ask to be forgotten or to have their data erased. And argue, and basically the reason they would do it is because they know that if they didn't purchase the product, they actually want their data to be used. They want the algorithm to know that they didn't purchase. It's a signal. They're signaling to the algorithm of their low willingness to pay. They want the price to decrease. So even though mostly, as we know from the literature, people kind of agree to cookies. Mostly, if you just look at the absolute numbers, people do tend to let the algorithm save their data, even if when it's not to their advantage. But like holding that constant, just looking whether there's a difference between whether it's affected by your decision to purchase. So it definitely does. And importantly, I think it doesn't happen in the fourth round, right? Because in the fourth round, again, it's the last round, so there's no reason to there's no strategic reason. This kind of breaks down the erasure. But I'll talk more about it in Q&A if anyone's interested. I have an hypothesis about why that might be happening, and I think I'll just stop here because we're out of time. The inclusion slide, if everyone includes it, doesn't really bother going through. Sorry for going over time, and thank you for